on the private YouTube so that we can review them.
Oh, nice.
Who are we missing?
So is that record? Yeah, that records on the camera. That's the way it works, right?
Yeah, it's got a 32 gig chip in it.
Oh, come on.
We're missing Nathan Clark. And even though he's not in the class, Jordan comes. Jordan has another class at the same time, but he likes to come here because he doesn't like that class. Yeah, exactly. Sounds like me. If I had another class at this time, I'd probably come here.
Okay, just briefly, I'm going to show you. This computer is whacking out completely.
Russian driving.
Bad Russian driving.
Is that the one where
is that like the
rear
one?
end somebody in a motorcycle does a flip and lands on the
Ah, do you think that's real or not? I call.
Oh yeah, that one's bull on that one, totally.
Okay, here, I'll pull it up. Let's see.
If you have Facebook and you haven't seen it, then obviously you don't surf Facebook that much. Because
So that
it's
means
all
you
over
probably have a
Facebook.
wife. That was a while ago.
Yeah, it was a while ago.
I see more in school than I do at home.
You should learn at school. That's because, women are in charge.
Yeah, here it is.
Wait. Okay.
Oh, you need to do the distracted driving one that's on. Oh, we're not friends on
You know
Facebook,
what?
are we?
I don't know. What the fuck's volume? Okay. What I call bull on this. I call complete and total bull.
Oh yeah, it's completely bull. Are you kidding me? Going that fast?
Even though it looks really real.
What if it's one of those 1 in a million things you can never replicate, but it actually happened?
Watch this.
Boom!
Bull.
Yeah, totally. I've seen it before, but
I call bull. I don't know.
now if they had Russian accents, because they're required to have dash cams, I think they just had a GoPro or something in there, and
They're required to have dash cams?
in Russia, yeah.
Really?
Every single car in Russia has a dash cam. You need to look up the distracted driving one where the person just looks down for a second during the snow and just the oncoming semi just hammers the crap out of him and it destroys the truck.
It's one of the scariest things that can possibly happen to a snowmobile.
An avalanche?
I'll show you. I don't know.
That looks like an avalanche to me.
Buried them or not? But that's what a GoPro looks like about 3 feet under. These guys are dead. No way they survived.
Oh wow, look at that.
Watch the one guy how fast he starts going. No way.
Oh, this guy.
You're not seeing it.
Oh.
There you go. Get back to maybe. Oh.
No, you didn't. There's no way. Holy crud.
150 miles an hour.
This is really cool also in the way you can watch the snow sort of ripple. Oh no, that's not this one. Oh yeah, look at this. Look at how it goes just like a wave.
Wow.
And let me tell you, when it does it, when it breaks away like that, it heats up because of the friction.
Mm-hmm.
So when it stops, it turns to like ice.
Ice.
Oh,
It freezes.
that's
It freezes.
okay.
Oh, this one's just broke away. Look at this. That one's a little one.
No, they get pretty big.
What?
Huh?
You can shut the door. Yeah. Look at
machine's
that. Spreading off the top of that. That's a little one too.
Yeah. Well, usually
Couple
there's a
in here
couple
that
sheets
it's
that.
like sayonara, baby.
Oh, crap.
Yeah, like this one here. All right, this guy makes it out the bottom.
Beats it down?
Yeah.
Or he rides it down?
He curves around to the side because it comes down the chute.
I made it!
Boom! Yeah.
It's already starting to go.
Who is it?
That's just one.
My phone's on silent. It's this one.
That's a little one.
Derek's trying to shop again.
This is a little one. Wait, I can show you the big one.
Holy shit.
Look at the size of this
Wow, that's just gonna mow
thing. I
trees
mean, look at the
down.
trees. Yeah, those guys were done. He goes off. He's done.
Oh, he's gone.
Yeah, he's done.
Did they find him?
Probably at the end of the winter.
He was frozen in animation.
This guy lucked out. He just full throttled it out the bottom.
That's a good thing. They find you eventually. You still look good because you're frozen.
Yep.
Too bad you just can't have oxygen so that they can, they can thaw you.
Yeah. I've been right in that situation before. And man, it ain't fun.
Oh, that's nice.
Look at that guy's, look at that. See the size of, wait, look at
The
this.
size of the chunks coming
Look at
off
the
of
size
there.
The chunks coming down. He didn't make it up. So watch this, look at the size.
Right there. Boom.
Look at the
That's
size of that, like the
huge.
size of a truck.
Like a semi-truck, I think is what it meant.
Anyway, that's death on snow right there. Wow. Okay.
Ah, they're French repairs.
Okay, do we need to
That's
review
nice.
anything from last week? We talked about, let's see, we talked about, what did we talk about? We talked about pipe lengths, pipe drawing out, remember pipe suction? We talked about the supercharging effect of a sonic wave.
Pipes.
Remember that? Dad is standing at the exhaust port going, no, you can't come in here. You know, so what else? What else?
Talk about cold seizing and
Cold seizing,
fuel velocity.
bridged exhaust ports. We talked about bridged exhaust ports, and remember we laid out the ports on the board, right? Any questions about what we garbaged out last week? Well, it's pretty heavy, but anybody have any questions in general about what we talked about in two-stroke so far? Or thinking about, I think I want to know a little bit more about this, or I didn't quite get this. Nothing?
Give me the points.
Yeah, have you ever heard of a car called a Porsche?
I was working on one for the last 3 hours, so was Will. And we did briefly get to the flame, or get to the combustion expansion, didn't we? In the combustion chamber,
Mhm.
lean mixture, rich mixture, good mixture, right?
Yep.
Remember, I know we hit that quick,
And
the
cold.
view wasn't real good on that
Cold
overhead
uses.
projection. But we looked at it as individual drops, you know, when we were looking at the combustion chamber and the piston to smash that fuel air charge up there, even though it's molecules and not drops. But the expression in the book was, was like little raindrops. Just remember that the lean, we're talking two-stroke here, the lean is the killer. And you might think, the lean is really hot, and you've also heard the term, and it is true, leaner is meaner. The leaner you can get a two-stroke and make it survive, the more power that you will get. But it's really, really hard on the motor to run that ragged edge. And this is why. Here in the mountains, with our mountain valleys and the way they're constructed and the way the wind blows through them and whatnot, you'll be perfectly tuned in one valley. So you're in there with your buddies, and there's all these great beautiful slopes, and you chew them all up, and you mark them out. Okay, we got to go to a different place. So we'll go up and over the top and down, and we'll hit a dead spot where the air is actually different. And anybody riding on the edge, they're full throttle climbing a hill, they'll lean burn. If you're running on the edge, in one day, your air can change. Depending on where you are, your air can change in location, not just elevation, because we know that air density changes for elevation. Okay, it gets thinner as we go up. But there's two things that control air density. Okay, two things. That's elevation and temperature. Air density is controlled by elevation and temperature. So whenever you're tuning a two-stroke, if we open, I don't know if we have one the right year. If we open the mid-90s, before EFI stuff, on almost all the clutch covers, the clutch guards, they'll have jetting charts. And the jetting charts are, down this way, and then they give a jet size. And over here, you'll have temperatures, or let's see, down one side, you'll have elevations and temperatures. And then elevations and temperatures with changes our air density. The colder we get, the leaner we get. The higher we get, the thinner the air gets, less dense as we go up. So we can reduce our jet size as we go up in elevation. Now, two-stroke motors are like people in here. The diversity on what two-stroke motors, how they treat you. You could have 600 cc motors, but we'll take one from each of the major manufacturers. We'll take a 3-cylinder Cat, we'll take a 3-cylinder Yamaha, a 2-cylinder Rotax motor, and a 2-cylinder Polaris motor, all 600 cc's. Every single one of those, even though their displacements are the same, every single one of those will jet completely differently. They have attitudes like we have fingerprints. They really do. And what's really strange, when you really get into this, you could take 10 of the exact same snowmobiles or whatever, ATVs, and they're in their crates, stacked 5 high. You take them all out, you build them, get them all ready, and one of those 10 always runs better than the others. And they're built at the same time. They could be sequential serial numbers, and it does not freaking matter. One will always run better than the others. It's a strange deal. So motors, just like people, have personalities. And you start slicing people's brains open and modifying them, you can really change, or you whack them into a wall or something like that. People's personality, you can really change their personalities quick, okay? So you need to be careful when you're playing with two-strokes and jetting. The best way, by far, bar none, to tune a two-stroke is with with a grenade. Boom! Is with an exhaust gas temperature gauge. Exhaust gas temperature gauge. Here we have our cylinder, our two-stroke cylinder, and we have an exhaust flange usually, or that's a terrible exhaust. Exhaust flange, and then we have either our wide pipe or our pipe coming out, and eventually this might couple or might not, and it goes into our expansion chamber. Our sonic waves. Okay? Now, by far the best way, when we build heavily modified two-stroke motors, you spend all this money and you spend 8 hours, 9 hours, 12 hours per cylinder porting it and everything. And all this time, and you go out and you're one jet off, you just fry it and you're back at the beginning of all the money. So you really got to be careful. So you invest in proper instrumentation. What it is, an exhaust gas temperature gauge usually goes either between 7 and 9 inches from the piston. From the piston, and there's a little probe that drops in, like this. And that, you drill it in, you either weld the bung in the pipe or it's strapped around, and that goes off to your EGT gauge, which is on your handle. That will run, now you have to baseline it, but normally at full throttle, 1150, 1200 is safe, 1250 starts to get scary, 1300 you're going to go. That's 1300 degrees. And it will, the good gauges, the EGT, exhaust gas technologies, I mean, if you blow it, it goes whoosh, whoosh, back up. And now that's how fast they read. Wow. That is the way you tune your two-strokes. If you're going to modify a two-stroke and you're going to put money into it and you want big power, if you don't do this, it's roulette wheel. Well, let's see if it lands on red. Let's see if it lands on black. Red means I burn down. Black means I'm okay. So, I mean, serious, that's how bad it is. Instrumentation for modified two-strokes. Okay? Instrumentation. One of the last things, or a couple of last things I wanted to talk about. Okay, we're looking at our piston from the side again. We're looking at a piston from the side. Here's a two-ring, two-stroke piston. And there's two major types. There's our piston pin. Here's our next one. We have a dome top and a flat top. Losing my pen. We'll have a dome top and a flat top piston. Okay? A flat top, well, I shouldn't go like this. I'm talking combustion chambers here. A dome top piston is the same as a hemispherical, you know, hey, I got a Hemi. Well, I'm sorry, but half the two strokes on the planet are Hemis in every single portion of the planet's end. But they don't write Hemi on them thinking they're cool, you know. Give me a break. So, you have dome top and you have flat top pistons, okay? These things can really squish it down. In other words, your piston can come way up in there. And you can run them. I wish it, can I explain why with a flat top piston, you can run really lean. And so you can pull a ton of power out of it. That little 3-cylinder 600 Arctic motor, man, you run those lean, flat top with no deck height. And deck height is the distance from the piston to the head at its narrowest point, right here and right here. Minimum deck height. Because if you start modifying a two-stroke, you cut the head. That's very, we're going to mill our head. Minimum deck height on a flat top piston. Oh, I don't know if I should tell you this. I'm going to tell you a range. Minimum deck height is 35 to 40 thousandths. So that's a millimeter. Just short, that's minimum deck height. You go below that, at 10,000 RPM, the piston is stretching, the rod is stretching, you're going to whack your cylinder head. But not only that, it's not necessarily whacking your cylinder head. When it gets really tight in here, what happens when that piston gets really, really close to the head? What do you think happens? I'm not hitting it. I'm combusting, but I'm not hitting it. What do you think happens? Give me an idea. What do you think? If our deck height is way tight, works on the same thing with 4-stroke motors too. But heat transfer, we get hot spots. Okay? Hot spots are very bad because hot spots will get hot enough that they'll ignite the fuel. And so you're igniting your fuel, your flame throat starts the other direction like this. Your spark plug lights this one. And you get that knocking, that's where you get that knocking sound. It is very, very, very hard to hear. In a car, you hear a knock, it goes in a two-stroke, it's very hard to hear. Especially if you got pipes on there and stuff, you're like, what? Huh? You know, because they're so loud. It's very hard to hear a two-stroke knocking. You have to really have been around two-strokes a long time. I can hear most of them when they knock, but not all the time. Minimum deck height on a flat top piston is 35, and that 35 is the bottom. Race motor, 35 to 40. On a domed piston right here, nothing lower than 50. Deck heights are 50. Okay? So when you start messing with these things, you can test your deck heights. How do we test? My favorite way, but what's the easiest way, Brad? What do you think? Have you ever done any deck height tests? Not really?
No.
Did I show this?
You can do it with a few. Oh, you can use some.
I showed you guys, didn't I show you guys?
Yeah, you can use solder.
Solder.
Yeah.
So we'll get a 60,000th piece of solder, stick it in your spark, make a little L out of it, stick it in your sparkler bowl, make it sure the end drags against the side of the cylinder, bring it all the way up to the top, hurry. This will come up, whack, whack, whack. Smash the solder, take it out, take your micrometer, measure it. That's how you do a deck height test. That's how you do it on a Porsche. That's how you do it on a two-stroke. That's how you do it on everything. Now, we're looking down the top of a piston. Right here, it's the top of a piston. This is our pin underneath, holding it to the rod. Okay? When you do a deck height test with your solder, you don't stick it and put it over here or over here. Because the piston rocks in the bore and you get an inaccurate reading. Remember, when you're doing a deck height test, you have to do it in line with the piston pin. Right there. Okay? If you do it here or here, when it comes up and hits the solder, the piston will rock like this. And it'll give you, oh, I got 55 thousandths. I can cut another 15. And then your deck height goes to 25 and kablooey. Okay? Incredibly simple things that can make a monstrous difference in, oh, I'm burned down on the hill and here's another $400 or $600 at the motor. I'm stuck on the hill and have to tow me all the way out. And my buddies are going to go snowmobiling all day and leave me here until they come back and pick me up. You know?
Yeah.
So, that's all happening.
It's like something you have to experience.
Yeah, you tell I've been scarred for life. So, remember, deck height tests are done in line with the piston pin. Deck height tests are incredibly common in two strokes to know where you're at, okay? Okay. Now, we don't have, sometimes these gauges, the Avenger 2s and Avenger 3s that I used to use for my exhaust gas technology, they don't make anymore. They call them race packs. And you get them just single display, so you can have 2 exhausts in and maybe 1 coolant temperature in, you know, and then you can scroll through your screen, you know, exhaust 2, rotation 1, or RPM, you know, and heat temperature. Like one display will have 4 inputs, and you can just scroll through them, okay? And that little thing with its probes can be like $600. So it's not cheap, but you can move it. You just take it off once you're tuned, take it off, and put it on the next one. Okay? It's important that if you do not have the money for exhaust, because that ain't chump change, you know? That's an expensive gauge. This is how you jet your snowmobile. The first and safest way, not safest, but the easiest way, but not always true, is like we do with everything else. We pull a spark plug out, and after what you have to do, whenever you check jetting on a spark plug, you have to do a full run, hard run at top speed, you know, full RPM, and shut it down at top speed. If you come down and look and putt around, oh, I think I'll shut it off, check my plug now. Hey, full run, shut it off. Pull your spark plug out, look at your color. Okay? What is our best color? What do you think? Has anybody ever played with the spark plug color? If you have a brand new spark plug in there, it won't have any carbon on it, so you'll come out and still be that same. And you're like, oh, you have to go drive.
The rustiest looking color.
It is the color of a regular, off-the-shelf, 99-cent Hershey's chocolate. Not the dark chocolate,
Regular chocolate.
not the white chocolate. If you get the white chocolate color, most likely you're done already. You're way too lean. The lighter that brown goes, the leaner you go. Okay? So if you're a light brown to a tan, I wouldn't play that game. I mean, we played that game on the flat top ZRT motors, this flat top 600 motors, but we were racing them, and so we were playing the edge. You want the color of a regular Hershey's chocolate bar. It's the best way. Everybody knows the color of a chocolate bar. Not the dark chocolate. Dark chocolate means you're rich. Not the light white chocolate because you've burned down already. Okay? So, Hershey's chocolate bar. Okay? That's optimum plug color. But that is still not the best way because plugs can fool you. Mostly because people are checking them at the wrong time. This is how we do it. If you look at my toolbox, anybody who does a lot of two-stroke work, you open up the toolbox and there's a bendo light. You know, there's one of those lights go like this, about this, and you can bend it all around. It has a little LED on the end, or a little light. You know, you can't use one of those high-dollar scopes to do the same thing, but most people just use a light, They go down in the spark plug hole and they look at the top of the piston. And this is what you're looking for. This is knowledge acquired over 28 years that I'm just blowing into your head that you're learning in 3 weeks. You all knew how lucky you were. We're looking at the top of our piston through a spark plug hole. You know, you can't see the whole, you look through the spark plug hole, you can't see the whole top of the piston. But if you have one of those wash lights, you go down and you can just look around the edges, you know, like this. Remember our port layout? Exhaust port, intake, 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 and then we got half the intake exhaust around over here. Where your intake ports are, here, 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 that's where the fuel is coming into the cylinder, right? As soon as that piston comes down, compresses that air-fuel mixture, gets past the top of the intake ports, compresses it, comes flying up. We understand that, right? What it will do is it will drag a fuel-air mixture across the top of the piston, right where the piston and the port meet. Okay? So we're looking at the top of the piston. If I'm looking at the top of the piston and want good wash, which is how you tell how because all pistons will get carbon, no matter what, especially two-stroke pistons because of the oil in them. So they get black. You know, you want them black. You want them to have a nice black mark. Where these exhaust ports are, this is what you want. On a round top piston, you'll want a clean spot about that big. Here's the back, the clean spot about that big. Now, in a real perfect world, those clean spots would look just like perfect half moons, okay? But in the actual, gosh, the last time I talked in here, I didn't have a pen either. Most likely, you take an average of what it's supposed to look like. So this one might be a little shallow, and then you'll be a clean like this.
I got one in my truck.
I got one in my office. But in order to make this, I have to have a good pen. Off the brain.
You can play for the what?
Spaz.
Jazz. Play for the Jazz.
Okay, let me go get this. I really need you to see. I really need you to see this.
No Jordan today, huh? He gave up last week.
Yes, plus the
Going to the what is it like art history? I think is what he's
No, it's
doing.
not art history, it's like
Oh, it's
art communications or something.
yeah, it's where they lecture the whole
I
time.
stole them from the diesel guys. Oh, you better not say a thing.
Whose classroom was it from?
He's borrowing it from the diesel guys.
Oh, yeah.
You can see it.
So, we're looking straight at the top of our piston. This is carbon. And these are clean little aluminum spots. Okay? But, in the optimum world, these nice, clean aluminum spots would look like this. And that's good wash. And the reason they call it wash
Because it's washing the carbon
is because it's doing exactly that. The acceleration of the fuel air oil charge comes into those ports and washes the carbon off the top of the piston. Because right when it opens, you have a higher fuel velocity and it just comes in and washes it right off. Okay? That means you've got enough fuel. This is what happens. When you get leaner and leaner, those spots start to tighten up. Like this. Okay? They start to tighten up. Now, is your wash going to look like this? Right now. It's going to look like this. It's going to be like clean like this and go like this, and then you have a spot and it's going to be clean, and then your exhaust port goes away. And then it might go over here and be clean, and that's more what it'll look like. Okay? But what we want is if we could take an average ring around this thing, if we could take an average ring, that's your piston edge. If we could take the average ring of fuel, we would want an 1/8 to a 1/4 inch of wash on a round top, on a dome top piston. Okay? When we go through, when we're done here today, the cabinet's open. Hopefully the Zerk motor will have a little bit of wash on it and the Ski-Doo motor, and you'll be able to see it. This is how you can inexpensively jet your 2-stroke perfect. This is how you do it. If you don't have a $400 or $500 or $600 gauge for exhaust gas temperature, which is the best way to do it, this is the way all the old timers did. And the old timers still do it by wash. Okay? They do not do it by color. Nobody goes, oh, that looks pretty good. No. They look at the wash. Okay. This is a domed top piston. Flat top piston is different. Okay? We have a flat top piston. Ooh, love that. On our ZRT motor, most flat top motors that I've ever seen are smaller displacement. I've never seen a big 5-stroke 900 or 1000 cc flat top motor, unless it's a 3 or 4 cylinder. But most of the big displacement motors have dome tops on them. Just smaller flat tops. There are several bikes that have flat tops too. What we'll get with the flat top piston, we'll just get a little speck. Like that. Much harder to read the wash. You get a little speck, and that is good. If we have wash like this on a flat top piston, we're way, especially if we have a ring like this, we're way rich. So the wash flows out different over a dome piston and over a flat piston. The reason is the shape of the piston, you know, when it opens, remember the fuel's coming up at that angle and it sort of washes it off. The flat top piston is like this, and the fuel sort of shoots over the top of it and just nicks the edge. So it doesn't give you a true all the way into the piston wash mark. Okay? Everybody can see one of these through the spark plug hole with one of those little bendo lights. Now, it takes a little practice, you know, because you're looking through the spark, and the older you are, Andy, sorry, the glasses and everything, it gets harder. But you wash light down along the edge, you drop that piston down to the bottom, and you can see that wash plain as day. It's easy to see. That's how we read wash. Okay? That's how you do it. That's how you'll read your jetting. As you richen it up, it'll wash out more. It will usually never wash all the way out, unless if it washes all the way out. Darn things, not enough. It just will not. Okay, concept, everybody get the concept, sort of what I'm talking about. And I think you understand why it happens now. If I talk to you about wash before we start talking about 2-stroke, is that the washing machine or is that the dryer? No. Now it makes sense because we know the way the fuel enters the motor, you know? It all starts to fold together. Any questions? Andy, anything? Everybody got it? Sort of? Yeah. You weren't here for last week's lecture, were you? You missed it. You missed it. I threw out so much information that Andy's head was starting to grow bigger.
It's true.
Okay. I don't think I really want to teach you any more about 2-strokes. What I want to teach you from now on out is just take them apart and put them together and having you recognize the parts like we've been doing, okay? But some basics here. Andy was waiting for this. When I rebuild any motor, even 4-stroke motors, I use 2-stroke synthetic oil to lubricate the things that need to be the slickeriest. Okay? This is 100% synthetic Redline Racing 2-stroke oil. This is, as Brad will
the only
agree,
way to fly.
this is the slickeriest stuff on the planet, besides Lemon Pledge. Lemon Pledge is a little more slippery. So, if you need to get a piece of rubber this big over something this big, spray it with Lemon Pledge, and it will work. We have this kit. We take CD boots, you know, and you know how big the hole is on a CD boot on the shaft side, and we stretch them over the CDs with Lemon Pledge, and this little cup thing that we got for ATV, you know, half shafts and CDs. will stretch that little hole all the way over a CV.
Wow.
With lemon pledge. And lemon pledge is the only thing you can use to do that. So when you're putting in windshields, has anybody ever put in windshields with like the rubber gasket around, like slugs and stuff? Lemon pledge. That thing will go and suck right through, and then the lemon pledge dries off and just works perfect. Slickeriest stuff on the planet. When you're building motors, you can use any synthetic two-stroke oil, but Redline is the best. I know you're going to get different people that say different oils, but in 28 years, this is the best stuff I've ever seen. And anybody that uses Redline, okay? This stuff right here.
Ultra blank.
See this?
Ultra.
The devil himself made this and put it on this earth to torment man. We do not use this unless we absolutely have to.
Because it sticks to
We never use it. I swear to Buddha, he'll roll over in his grave because the devil put this on. We do not use this. We do not use this in two-stroke motors. We do not use this in four-stroke motors, semi-hand. You just do not use it in a pan, in a plane, with a train, on a stand. You just don't use it, okay? So silicone is, I don't know what they teach you over there in diesel, but this stuff, it's of the devil. But you've heard me talk about it. Brad's heard me talk about it. Andy's heard me talk about it. Don't use it. Don't use it only when you have it. On my two-stroke motor, the only silicone I will ever use is this, and that's just if I have a used exhaust gasket, flange gasket, that I have to put on because it gets smoking hot and I need a little seal. This is the only spot that you will ever see a little piece of silicone on any motor that I ever build, ever, because this stuff is safe. Okay, it's pathetic. And I just spent 3 hours from some guy to put a Porsche case together with this. Scraping, scratching. It was all in the oil pickup. You know, because they take a bead and they go, you know, our crankcases, everybody saw them, they're hard over there. They'll take a bead of this crap and go, and those crankcases smash together and only use like 1/10 of that goop. Where do you think the other goop is going? Now in a two-stroke, it'll fly down around in there, eventually fly out the port, get jammed in there where I burn out about the exhaust port. In a four-stroke, it's going to go down and it's going to clog up your oil screen, okay? And you're going to have, yeah, it's going to get through there, it's going to get in an oil jacket, and you're going to have a rip on a bearing and tear it all apart, okay? This is our friend. This is what we use to put together mating aluminum surfaces. It goes by many names, but it's made by 3Bond. That's the company name. They just, Permatex packages it as MotoSeal. Yamaha designed it. Yamaha designed it to put together those super high revving bullet light cases. That's what they designed it for. So, because you're going to get shuffled at 15,000 RPM. This stuff never dries hard. It stays soft. It's anaerobic, so it dries without the presence of air. Okay? I want everybody to take a look at this. It's either called MotoSeal or Yamabond 1194 3-bond or 1104 3-bond. I think 1104 got replaced with 1194, but you've seen it before. We played with this. This is the juice. Pass that around. If you want, take a little sample on your hand. It's already sort of,
Beat it.
yeah, sort
Take
of
a taste.
skinned over. You need to know how it smells.
Gross.
That's what we use, okay, to seal our metal-to-metal parts. Any metal-to-metal parts that are the same metal, steel to steel, but any machine, high-performance sealing surfaces, which most small motors are. This is the go juice. This is the devil. Okay, remember that.
Smells like
Take my advice,
Carb
please.
cleaner.
'Cause if you think, oh, I like silicone better, Just wait till either you have to take it apart or the next guy has to take it.
I like that.
And it does not
I'm gonna
work.
start huffing.
Silicone does not.
Just kidding.
Use Moto Seal, and you might live to tell about it. Okay? So, that is the sealant we use. So, 3-bond, Yamaha bond, you can get it from Yamaha dealers, you can get it online. It's great, and it's sort of pasty, but what's really strange
Tasty, too.
is I'll take this along a nice, clean aluminum surface, and you know, when I drag it along, it looks sort of rough, you know, like my fingerprints or something. You let it sit for about 30 seconds, and it just smooths out. With a little thin layer a layer almost that you can see through. You know, you can see the little specks and case. And on the other half, same layer, just put your parts together. You don't get the big Mr. Blob out both sides. It's going to clog up your screens and cause your high revving 4-stroke bike to seize up. Kawasaki. Kawasaki's would be right. We used to pull apart Kawasaki's, and their oil screens, which were only about this big, would be full of case sealant. And the motors would be burnt down because they overdid the case. Okay? Now, other than that, the only other thing that I care about, I mean, everybody will build things with their own glue. You go on the forums, whether, I don't care which forums you like. There's a thread on there about sealants and glues. And everybody's got their own sealant and glue, you know. But this is the king of small end, okay? And so use that for your metal to metals, okay? Now, that's not for the rough metal to metal. What I consider a rough metal to metal is like an oil pan onto the bottom of a crank, you know, bottom of the case. Sometimes those will not have gaskets. There are some that don't have gaskets. We use the foamy, air-filled silicone for those. Not the shiny black stuff. Blue. Next time you go into O'Reilly or AutoZone, take all the blue and start throwing it out the window. And say, I'm just doing you a favor, because the blue is nothing but, I don't even know why anybody would even attempt to use it as crap. The blue is junk. It doesn't hold for nothing. Anyway, also, JB Weld is our buddy. Okay? You can fix anything.
Love JB Weld.
2 strokes, just so you know. I'll write it on the desk. The bottom of our crankcases. So remember, we have our crankshaft is, we're looking down the end of our motor, our crankshaft. Here's our crank wheel going around. This is the center of our crank wheel, and it's coming out like this. Our crankcase is half, and it squishes on that seal. But that distance there in the bottom of your crankcase, this distance right here, is very tight. Very, very, very tight. I've seen it as low as 3 millimeters. Okay? That distance. So when we have a piece of foreign object finally enter our crankcase, either a screw drops in or a piece of piston skirt breaks off, it'll go around there, it'll get jammed between the crank wheel. You know, this thing's ripping around at 150 times a second. That little piece of whatever comes right down here, the crank catches it, and then it goes like this. Got blue! Blows a hole at the bottom of the crankcase. The crankcases are very thin. Okay, they don't need to hold a ton of pressure. Crankcase secondary pressure, you know, we talked about it, is like 12, 10, 11 pounds. We might test up to 13, that's it. You know? So, I have repaired the better part of 500 crankcases with our good buddy, right? Because it's not high pressure, okay? People think, no, man, well done up, it's got to stay in there. It's not high pressure. Vibration is our only issue, not pressure, okay? You got a good seal, or a lot of times what will happen is that screw or piece of piston skirt will just bang it, and it'll just make a thing like this, where it's all cracked, you know, but it's not a hole. You just take your crankcase apart, you tack that back level, you grind the whole surface. It has to be ground and rough. And clean with carb cleaner, you put your coating of JB Weld on there. Use the 24-hour stuff. Do not use the quick. Do not use the quick.
Do you put it on the inside and the outside, or
You
just?
can, if you're a little worried about the seal and everything, here's the issue. If you use the inside on those crankcases that have the really tight clearance, you're going to maybe have to clearance it with your porting tools or with a die grinder. You know? Or you could just put a nice thin coat and you'll be good. Front, inside and outside is a great idea. You can sort of cake it on the outside, you know, and make it
thicker.
But this stuff flows for a while, so you're not going to be able to put it on very thick as it is. The reason you don't use the quick stuff is the quick stuff is pastier. It dries faster, but it's thicker. And the reason this stuff is so good, the 24-hour stuff, because it takes like 2 hours before it even starts to set. So it's more liquid and it flows into those gouges you made with your die grinder. And it holds. If that surface isn't clean of oil and doesn't have some gouging from a die grinder, the JB weld's going to pop off in one giant piece. But if your surface is prepped, you can't chisel that junk out. Okay? You can fix a lot of aluminum with JB weld. Those are the only pieces, the only lubricants that you should really say, I think I'll listen to them. Okay? Do not use soy when you put together your stuff. Do not use it. A little ketchup bottle, or you can use those squirt cans, you know, of 2-stroke oil. Boy, once you've used it to build motors,
You'll never go back.
yeah, you never go away from it. I just put on all my tiny chain wheels and all that stuff as I'm building motors on my camshafts, rocker arms, everything.
So don't use this as
This is better. Well, assembly lube is great for contact points, you know, where you're going to get a hard contact. But, for example, this is what you use when you lubricate your cylinder walls in a brand new motor. Okay? Put a little bit of that, wipe that around. Okay? The parts that you might not necessarily think, oh, no assembly lube, but still have friction or contact, you lube it this way.
So like your
Like main bearings, rod bearings, and everything we use our assembly with. Still rotating contact surfaces, like I would use this on my hydraulic cam followers. I cannot call them lifters for some reason. Because they don't lift, they follow the cam. They're cam followers. Anyway, that's what they do.
hydraulic lifters.
But not lifters, they do lift, but they follow more than they lift. So, it's good stuff. Once you start using it, it's the slipperiest. It is 100% synthetic test tube oil. No mineral-based stocks at all. It is the only 100% synthetic. AMS oil, which is good stuff, still has like a 30 or 32% base stock of mineral base. Most synthetics only have to be this much percentage of synthetic to call it a full synthetic. You know, 60-something%, and you can call it full synthetic.
Basically,
no, it's a lie. It's not a full synthetic.
It's basically lipstick in a bottle right there.
Yeah.
It comes from the same source.
Yeah, it's great stuff. It's great stuff.
Tyler
And it's full.
used that full synthetic in his oil change today, and I said, you just wasted your money.
On what?
His Kia.
Oh,
What do you
yeah.
use, mobile
There's
one or
no
something?
reason for full synthetic.
Yeah.
Okay, we are done with two strokes. If you want to be done,
That's even worse.
I could go the whole semester on two strokes. But I've given you a good, this is more than I've been able to teach any students in small engines. Because this year I just decided to go for it. And really not just skip over and say an engine is an air pump, but I'm actually giving you how the things work. Does everybody get basically a basic concept of how all the two strokes work? Okay? You sort of got it?
Sort of, kind of.
Sort of, kind of.
Kind of, sort of.
Okay, that's a quick lecture. Let's go out.
We need to play this out.
The cabinet's open. I'm gonna see if those motors that I brought in here the other day. Let's go see if those have some piston wash on them.